Now, if we proceed down here, we have a System 360, which was IBM's answer to a particular problem that almost all manufacturers were having. And that was that everybody wanted machines with different characteristics. The scientific people wanted very large and powerful machines. The business-oriented people wanted machines that could not process numbers but process strings of characters. They wanted smaller and cheaper machines, obviously. And all of these types of machines were basically incompatible with one another. And at the time, which is the early 1960s, IBM had the situation where they had, I think, 14 different lines of computers supplying different kinds of applications. And all of these machines had to have huge teams of people writing software for them, huge teams of maintenance people trained on each particular line of machines, and also immense amounts of literature being published to train people for each of these machines. At the time, IBM was the second largest publisher on the continent, second only to the US government. All of these machines were rapidly becoming out of date, and IBM needed some new equipment. They attempted to design some new ones and realized that they were just exacerbating this situation. And so at one point in the early 1960s, they took all of their senior personnel and retired to a motel in upstate New York and basically said that we're not going to leave this place until we have solved the situation. And what they came up with was a whole new radical design. A machine that could process both scientific problems and commercial data processing problems, and that would have a range of models from very small for the smallest business establishment to the very largest for the government and military scientific applications. Also, the architecture, the internal construction of the computer was such that it could quite efficiently deal with all of these problems. When they announced this on April 4th, I think it was, April 7th, 1964, it basically changed the whole world of computing. All the other computer manufacturers in the United States certainly realized that IBM had a jump on them, and people like General Electric and RCA, National Cash Register, UNIVAC, and Honeywell, and Control Data thought that they had better get on the bandwagon. Control Data didn't. They decided they were going to stick with their very high-end scientific calculating machines, but almost all the others decided they had to follow suit. And they didn't have the resources that IBM had in order to do all the research and development on this new concept for a machine. And as a consequence, they one by one basically went broke. And that's why you don't hear of General Electric and National Cash Register and things like that as a major computer supplier today. One or two of them still do exist, things like UNIVAC, which have since merged with Burroughs to become Unisys, is still around. But most of the others simply folded their tents and quietly stole away. This was a gamble, a tremendous gamble. IBM spent, in the end, over $5 billion, that's 1960s dollars, on this. And had they lost, they would have simply gone bankrupt themselves. But as it turned out, they won, and they won big. Now, it's possible to do computing without using digital things, and this is just an example of a few analog machines. I won't talk about them here, but there is a whole different technology that at one time rivaled the digital technology of the modern computer, and it wasn't clear until the late 1950s which of these two technologies might in fact be suitable for any particular problem. It was only from about 1960 on that computers became powerful enough, digital computers became powerful enough that these particular devices gradually died. These machines here, these two black jobs, One is a Norden bomb sight, and this is a gunnery computer that was used to control the anti-aircraft fire from B-17 bombers. The machines themselves are exquisite examples of mechanical computing. Developed during the Second World War, this particular Norden bomb sight has 2,000 moving mechanical parts inside, highly miniaturized, but they needed this kind of computing ability to solve the trajectories of dropping a bomb. And in order to solve that, you have to input the speed of the airplane, the drift of the airplane, the height, and all sorts of other conditions. And then this basically will solve the differential equations of exactly what the flight of the bomb will be when dropped from an airplane. And it was one of the things that allowed you can't quite call it precision bombing, but not the absolute random bombing that preceded it in the Second World War. Now, we've only got a few minutes, so let me just wander in here. Now, the machine you see behind me, or behind you, is a machine known as the Digital Corporation, or Digital Equipment Corporation, PDP-1. And this company, Digital Equipment Corporation, was at one time a leader in the field of small computers. They produced many famous machines, but this particular one here is of interest because of the very large scope, which was an optional extra that you could add on to the PDP-1. This optional extra was on a machine at MIT, and the students at MIT thought this was a lot of fun and decided that they should use it to play some games. And so they programmed it with a game that they called Space War, where two rocket ships could fly around shooting at one another, and the background was a set of stars that were a realistic constellation. The flight of the rocket ship was influenced by the gravitational effects of the various stars as it passed by them and things of that nature. So it was really quite sophisticated, and it turns out to be the first sophisticated video computer game. Became very popular with students at MIT and was eventually actually commercialized. And some of the machines that you see in the back corner over there are the commercial versions of this that showed up in university cafeterias and things of that nature. Now, the PDP-1 has an interesting story behind it because there were two potential contracts for Digital Equipment Corporation to first build this machine. And it was built to control various bits of equipment and to read the values that these instruments were trying to detect. One was from the American Geological Service, and the other was from the Canadian Atomic Energy Authority, both of whom wanted the machine, as I say, to control equipment. Digital agreed to this, the contracts were set up, and before the machines could be actually produced and delivered, the Congress in Washington decided that since computers were so expensive in the early 1960s and that everybody seemed to want one, they would pass a law that said no U.S. government authority could buy another computer until all the ones in Washington, D.C. were fully utilized. This actually made some sense in that day, but that seems to be rather short-sighted now. At that point, the Geological Service came to Digital Equipment Corporation and said, "We're very sorry, but we're not allowed to buy a computer." And people from Digital looked at this legislation very carefully, and the legislation clearly said you could not purchase a computer, but it didn't say anything about a programmed data processor. And so the name of the machine was changed to Programmed Data Processor 1, or PDP-1, and the machine was sold to both the Canadians and the Americans. And from that point on, Digital just kept the name PDP for all of their equipment. And you can see quite a substantial collection of Digital Equipment Corporation machines down here, PDP-5s, PDP-8s, PDP-11s, and all sorts of things, which I'll let you look at yourself a little later. Around this room, you'll find another exhibit that is more highly curated, because we were asked to create an exhibit to show the innovations that have occurred here in Silicon Valley. Intel asked for this. We quite happily agreed. When Intel was finished with it, and they used it for a special event that they were holding, the exhibit was simply shipped back here. And as that's a fairly highly curated exhibit with good signage and things, I'll let you look at that one by yourself. There are many examples in there of very early things from Hewlett-Packard, the first microprocessors that were ever created, the development of the Palm Pilot and things of that nature. But along this wall, what we have is a small sample of our collection of personal computers. And we start off by the thing in this case here, which is one of the original Apple I's. It wasn't called an Apple I, of course, it was just called an Apple in those days, and the one wasn't attached to it until after the Apple II came out. Two of the local boys here, Steve Jobs and Steve Wozniak, were responsible for creating this as a hobbyist machine, and it proved to be so popular that they made 220 of them, a large number of which were sold at what was called the Bike Shop, which is only about 2 miles from here on the corner of Grant and El Camino Real. The original shop no longer exists, but that was the main sales point. Cost $666, and what you got was a bag full of chips on that green board. And you were responsible for, first of all, creating something to put the green board on. And you see a fairly crude wooden case here being done by this particular hobbyist. You were responsible for producing a power supply. You had to have your own television set to act as a monitor. You had to produce your own keyboard one way or another. And the machine itself was, although of interest to hobbyists, certainly not a machine that could be used in any way by somebody who was interested in just having computations done. Now, although it only cost $666 when it was new, it turns out that when the Apple II was produced, they offered this as a trade-in. You could trade in your old Apple I, and almost all of them were in fact traded in on an Apple II. And so of the original 220, very few exist today, and consequently they're fetching very high prices on eBay. I think the last one went for $18,000. We actually have 2 of them here, and if you want to see what a different kind of mounting looks like, it's in the more curated exhibit over there. You can have a look afterwards. This represents the development of the personal computer, which basically all started with this machine here from Xerox PARC. At the time, in the computer world, almost all computers used what was known as a command line interface. You typed in very cryptic commands, and the computer would then do something. People from Xerox PARC decided that they wanted a machine that was a good deal more user-friendly. What they wanted was something that could mimic a piece of paper on your desk for writing and editing and things of that nature. So when they even produced it, they produced this display that was 8.5 by 11 and shaped like a piece of paper to give that illusion. The inventor of the mouse, Doug Engelbart, who's again on that more highly curated display over there, joined in the effort, and they hooked up his mouse and what's known as a corded keyboard. And the machine basically pioneered what today is usually called the Windows or graphical user interface. Xerox unfortunately didn't exploit this. They They attempted to exploit it in various ways, but it was all a commercial failure. The exploitation was really done by the Apple people, who, when they saw this, decided that this was a proper way of having humans interact with the computer, and they then produced this Lisa as their first effort. The Apple Lisa was a commercial failure. It was overpriced and didn't meet the market demands. But their second version, the Apple Macintosh, certainly was the commercial success and led rapidly to people developing this way of using a computer that was more by using a mouse and clicking on icons than it was typing in cryptic commands. A few other things to note here. Almost everybody can find some kind of machine that they originally worked on, but this particular machine right here, this big box, is the very first laser printer. It too was produced at Xerox at the same time that they were working on this graphical user interface, because of course if you have the ability to have the piece of paper simulated here, you have to have some ability to get that piece of paper printed out in a reasonable format. And the best way of doing that was to try and simulate a Xerox copier. And so this is just a modified Xerox copier. And instead of placing a piece of paper on the glass, it was actually painted on by a laser onto the drum. The copier itself originally ran at 45 pages a minute when just being used as an ordinary copier. And consequently, this particular machine, when it was being used as a laser printer, also ran at 45 pages a minute, which of course is about 10 times faster than the common laser printer that you have in your home office situation today. At that point, we have been almost an hour on this tour, and I'd like to just invite you to come and look around. You'll find other people here dressed in the same type of blue shirt that I have, and they would be happy to answer questions. Do have a look at the other exhibits here. As I say, there's absolutely no way we can talk about them all in an hour, but you're happy to, you're welcome to look around. And at that point, we'll leave it. Just the last thing is, as you leave, there'll be a little form you can fill out, a tour feedback form, and we'd like to get feedback from our guests. If you could just stop for about 30 seconds at the front table and fill out a tour feedback form for us, we'd appreciate it. Thank you. Now, I get bored doing that all the time, and so I don't.
Because of you.
Every time I do it, I'll try and talk about something else. You know, I will spend more time with the Norden bomb site, or I'll spend some time, we didn't go into that room with the Cray 1, Cray 2 and things like that, because I realized that time was getting short. I'd overdone my tour. Now, if the people are here, I might have said, okay, you know, there's at least 1/3 of the place we haven't seen. If you have time to stay, please do, and we'll, you'll find me in that room, and I'll be talking about things. But on the other hand, if you don't have time to stay, well, do come back another time. I'll look at it. Almost all the time, I will try and work something new in, just because I get bored if I keep...
That's marketing too.
Yeah.
See how the reactions of people.
You're not alone. Victor Borge always did.
Yeah. I'm not as good as Victor Borge.
World's best entertainer.
Why don't we go and you give us about a 10-minute thing on the Lamer sieve, so we can all learn a little bit about it.
Okay.
Just a little bit.
Okay.
Okay?